I'm going to switch to English because our next presenter and our best practice that we're going to see is English speaking. So I'm very happy to welcome Neira, and she's going to present to us her project from the TU Braunschweig, and she will present the flow wall. So this is something that is very special because it's about climate change. It's about the coastal regions that are very much at risk for flooding and all the different climate change risk. So she will show us how they invented this flow wall that could protect and preserve coastal regions. So Neira, let's see, the screen is yours, and we're very happy to see what you invented with your flow wall.
My name is Neira Babovic, and I'm coming from TU Braunschweig, where we are actually focused on investigating and researching large-scale additive manufacturing, especially for the application in the construction industry, paradigm shift of the construction industry in terms of fabrication and the materials. However, our new focus is application of these novel materials and understanding where the application of additive manufacturing is and should be prioritized. So we understood that this is in the context of climate change could be actually at coastlines, and we are trying to redefine what we perceive as the future urban coastlines. So aside of the hazardous risk when it comes to flooding, we understand that one other risk for marine environment and generally the future of marine environment is as well loss of biodiversity. So we propose a concept known as flow wall that is defined as ecological and individualized coastal protection. What are the actually aspects of the flow wall? We are understanding that the previous way of creating the coastal protection structure was defined as fortification or armoring of the shoreline, and we are now trying to anticipate the negative aspects of the possible obstruction of environment that the structure can impose in these conditions. And we are trying to do something different this time by having conscientious design, meaning avoiding mistakes and mitigating the effect of the structure on the local species. So we are simultaneously trying to use additive manufacturing for rapid manufacturing of coastal protection structure with possibility of using recycled or local material. We're in the same time trying to follow the bathymetry and the very small spatial availability by creating the shapes that are fitting and integrating in the site-specific context, while creating artificial habitat for the marine mantos in context of surface roughness, pits, services, and other additional attachments to the wall. And we also understand that this has as well aesthetical benefit for the society at coast in terms of like non-monetary value. How are we actually planning to do this? These are the current advances in the large-scale additive manufacturing from our side. We are currently focused on, of course, shape optimization when it comes to wall, defining the thickness. When it comes to reinforcement, in the case of using concrete, for example, we are very much focused on efficient material use, and we are following the reinforcement based on the tensile stress isocurves to use as less material as possible. This is done either by bending of the bars or using simultaneously concrete 3D printing and wire and arc additive manufacturing. We are trying to define the form of the wall based on the, as I already said, bathymetry, but also based on the hydrodynamic influences and the imposing as high geometrical complexity as possible in order to attenuate the waves that are coming and refract them as much as possible. So we are focused on having also horizontal and vertical dents, and generally any kind of geometrical complexity that induces friction and therefore contributes to energy dissipation of the walls. And as I already said, for the artificial habitat, these microdents and just the rough surface, pits or holes, they seem very banal to us, but when it comes to the local species, they are acting as a shelter, they're acting as a place of possible uh, habitat, or they can also help to habitat connectivity between other parts of the local environment. And as banal they seem, the research shows that they are quite beneficial when it comes to species colonization of these structures. So we should focus on approaching the topic of the uncertainty by creating complex geometrical shapes that attenuate walls, but also try to implement the structure as much as possible in the marine environment that is not longer anymore human-centric design, but also designed for other species that are found in this environment. This is all, and thank you for the attention.
Perfect. Thank you so much, Neira. That was very, very interesting.